Hello everyone, this is section 9.1, Stewart Calculus Textbook edition 4. Okay, so this is the beginning of multivariable calculus. So first of all, we have to learn three-dimensional coordinate, rectangular coordinate system. As you know very well, let's see. We need this. So in two-dimensional coordinate system, the way we describe the location of a point in XY coordinate system is by reading how much you move horizontally from the origin and how much vertically, right? By A, by B, then this is point AB. Likewise, in the space, we use three-dimensional rectangular coordinate system like this. Let's say. So this is x-axis, y-axis, z-axis. You can view this one as a corner of the room down there, right? Like you're looking at from over that direction toward that corner, all right? So this is a wall, xz wall, yz wall, xy floor. Xy plane is floor. So when you have a point here, you can draw vertically going down. Let's say over here. And this is the projection. You can think about lowering a rope, okay, until it touches the ground. And from there, you read, now this is xy plane, so you consider find the xy coordinates by doing this. Right? This is A, B. So you have to go by A from here. Actually go by A this much, and then this much you have to go by B, and then you have to go up by C, and this is point ABC. Alright? And if you want, you can draw rectangular box out of it. Right? So going up like this. Point A, B, C. Then the projection point of this point onto the xy plane will be A, B, and z coordinate 0. Projection point onto the xz plane will be A, the y coordinate 0, z coordinate C. Projection point onto the yz plane will be y coordinate x coordinate 0 and BC. All right. Now, we call it P x projection xy, projection of yz, projection onto the xz. All right. Now, the set of all, we use this boldface R square is not really squared. This is the set of all real ordered pair of real numbers, right? Which means the set of all points in the xy plane. Likewise, all points in the space can be written as R cubed, which is the set of all ordered triples. Okay, ABCs are all real numbers. So this is set of all ordered triples. The set of all points in space. This is the set of all points in space. Okay? So, now, example 1. Let's plot the point minus 4, 3, minus 5, and 3, negative 2, negative 6. By the way, let me check recording is going fine. All right. Now, again, we want to draw this going this way. X-axis going in that direction, y-axis going in that direction. Z-axis. This is the origin. All right. So we are showing some negative part of the x-axis, negative part of the y-axis. X going negative form is not going this way, but negative. 1, 2, 3, 4. Right? And then 3 to y direction. So you can draw this. Okay, so minus 4 and 3 minus 5. 1, 2, 3, 4, 5. Going 5 that much. See? Same distance. 5 minus 5. Okay? That will be the point. Now, to have some three-dimensional field, you could do same distance 5, then you will have, okay, this is point minus 4, 3, 5. The main part is this, minus 4, and parallel to the y-axis to the right here, 3, and down by 5, okay? And the others are just to give you the feel. Okay? Okay. Now, down there. So this is up here. All right. You don't need to draw this rectangular box. You can just draw these 3 line segments. Likewise, here. X, Y, and Z. 1, 2, 3. And negative 2. So it is always helpful to draw at least a rectangle on the xy plane. 3, negative 2, and then going down there, minus 6. 1, 2, 5, 6. That distance. All right. So you can do this here. 3 minus 2 and minus 6. All right. Of course, if you want, you can draw. Okay. It's a rectangular box. Okay. So that's how you draw. Plot some of the points. Now, in the xy plane, if you have a y equals 2 equation here, the graph was something like this. Set of all points where y coordinates 2 is that x coordinate can be anything. 2, 2, 0, 2, 1, 2, minus 5, 2. Everything. Altogether, that will be horizontal line. And x equals 3 will be vertical line. Because the points whose x coordinates 3 and y equals can be anything, will form a vertical line. Now, what about in example 2? Graph the equations. EQS means equations. A, x equals 2, B, z equals -1, C, y equals 0, D, y is less than 2, E. Okay? Well, x equals 2 will be x coordinate. So think about it. Here, when you have x, y, and z, x, y, and z, x coordinate is 2, means every point whose x coordinate is 2 and y, z coordinate can be anything. Think about it. This is y and z. You have any point in y, z plane. 0, 2, 3, right? And then you add x coordinate 2, right? You have to move 2 units along x direction. In this point, also 2 units. Every point in the x, y, z plane, you just move from there 2 units in the positive x direction. That'll make 2 whatever y and z coordinates. So it'll form a plane 2 units away from the y, z plane, perpendicular to the x-axis. So, like this. So you can think of some plane. These are going in, this is behind. You can think of this as some kind of transparent, thin plastic plane. Alright? Going through x equals to perpendicular to the x-axis. Okay? So this is a plane perpendicular to the x-axis or parallel to the y-z plane through x equals 2 or 2, 0, 0. Z equals -1. XY coordinate can be anything as long as z coordinate is -1. So when you have an xy plane, you bring every point on the xy plane, a, b, 0 form, like a 2, 3, 0, -5, 2, 0. And then down by 1, -1. So that will be going through the z equals -1, some kind of plane. See? It's down there. Going through, oops, going through -1. So that means this will be dotted, hidden. You dotted ones means that you see through the transparent plane, and this is above the x, y. Okay, so it's z-axis, origin, x, y, and z. 1 unit down here, cutting through z equals -1, 0, 0, -1. All right. Y equals 0 means x is the plane. Every point in the x is the plane will have y coordinate 0. Okay? X is the plane. C, x is the plane. And D, now, and y is less than 2. Okay, I don't have to rewrite it. Y equals 2 would have been a plane parallel to the xz plane going through y equals 2. Y equals 1 would be going through 1. But anything y equaling less than 2 means this plane to the left side of this plane. Alright? So anything to the left hand side. Okay? To the left hand side of this plane. Not including the plane itself. What about this inequality between 1 and 3? Let's say 1 here. And let's say 2 is here. 2 parallel planes, right? Including 3, not including this plane. Everything in between, right? Everything in between. Of course, this one extends every direction. Okay, that would be the reason. Alright? Now, what about example 3? Graph the equation A, y equals x, b, y plus z equals 1. Now, in xy plane, so where should I put the line? Here. Y equals x would have been this in the xy plane. But let's imagine that you have z coordinate going up like this. Then, so this is x, y, and positive z. Then, any points on this is like a 1, 1, 0. Y, z coordinate is 0. 2, 2, 0. 3, 3, 0. Negative 1, negative 1, 0. What about the point unit up? That would be 1, 1, 1, right? Or 1, 1, 2, 1, 1, 3. All of them will satisfy x, y coordinate being equal, right? So any points above this x, y line. Or you can think about vertical curtain, right? The curtain through the y equals x line. All those points will satisfy this equation. Alright? Because all those points, when you make a projection onto the xy plane, you're sitting on xy line, y equals x line. That means your xy coordinates are equal. So, it's hard to draw in three-dimensional way. So, we would draw, in this case, let's say, slightly change the direction. X coordinate going this way, y coordinate going that way, and z coordinates going that way. Then, y equals x line, right? Vertical curtain. Obviously going through down also. Vertical curtain. Oh my god. Wait a second. Alright. Okay. Vertical plane through the y equals x line. What about this one? Same thing. This time, think about y and z. As yz, so if you think about yz plane, this is a line, right? Z intercept 1 going through y, right? 1, 1. Going through 1, 1. But anything vertical to the YZ plane. You think of a plane going through, right? It's perpendicular to the YZ plane through this line on the YZ plane, right? A plane through this line on this YZ plane, parallel to the x-axis or perpendicular to the YZ plane. That would be the graph of this equation. So, because we are dealing with three-dimensional space, when you have an equation, you have one restriction, right? Three-dimensional degree of freedom, but you have to satisfy one equation, one dimension degree of freedom down. So the set of points satisfying one equation in three-dimensional space will have a 2 degrees of freedom, which means a surface. It could be plane, it could be some curved surface. When you have a linear equation, you have a linear two-dimensional object. That means a plane. All right. Now, the next one is that you learn that when you have a rectangular box, okay, A, B, and C. And then it's hard to see. Sorry. Okay, so if you make a connection from here to here, longest diagonal through the rectangular box, what is the length of that? Well, first of all, you think about diagonal on the base rectangle. And then think about this right triangle. Let's say this is our length, capital D. And then this is C. And this length, let's say X. So you can draw this triangle. D and X and C. So you will have D squared equals X squared plus C squared. But from this base rectangle, you have A, B, and this is X, isn't it? Right? So another Pythagorean theorem, X squared equals B squared, A squared. Plug it in. A squared plus B squared plus C squared. Right? Therefore, the major diagonal distance will be square root of A squared plus B squared plus C squared. Okay? So, because of that, if you have a point I just drew a rectangular box out of this point. Let's say this is point x1, y1, z1. Let's say this is point Q, x2, y2, z2. Then this distance will be along the xy direction. So this distance will be y2 minus y1, y coordinate difference. And this distance will be what? Along the x direction. So x2 x2 minus x1. And finally, this one, z2 minus z1. This is our absolute value, obviously. Our A, B, and C. So whenever you have 2 points in space, we can draw from here parallel plane parallel to the YZ plane, XZ plane, parallel to the XY plane out of these points. Also 3 planes parallel to 3 coordinate planes. Those 3 planes and these 3 planes will make a rectangular box. And then the distance between PQ is the distance between the points, right? This distance between the points will be exactly the longest diagonal, like this. So according to this derivation, PQ distance is square root of a squared plus b squared plus c squared. So x2 minus x1 squared, y2 minus y1 squared, z2 minus z1 squared. Square root of x coordinate difference squared, y coordinate difference squared, and z coordinate difference squared. Okay? So it's just like the distance formula of the two-dimensional case. Stops here, right? You just have one more term from z coordinates. Okay? Now, using similarity, actually you can easily prove that this midpoint, alright, the midpoint between PQ, midpoint will be average of x coordinate, average of y coordinate, average of z coordinate. Okay? Again, extension of midpoint formula of the two-dimensional case, just one more coordinate, right? So this is the midpoint. Midpoint of the line segment PQ. Okay? You just take average values of x coordinate, y coordinate, z coordinate. So next up, example 4. Find the distance. Find the distance from point 1 to -3 to the following: A -2 -3 -4, B the xy plane, C the xz plane, D the y-axis, E the x-axis. Distance from here to each of those. Okay? Well, let's see. A is easiest. Just distance formula. That distance is x coordinate difference. 1 minus minus 2, so 2 squared. 2 minus minus 3, so plus 3. Minus 3 minus minus. So what do you have? 3 squared, 9. 5 squared, 25. 1. So 35 inside, square root of 35. Okay? B. Okay, let's draw the points in this x, y, and z. 1 and 2 and then down by 3 there, right? So 1, 2, down by 3. Okay? So if you draw a rectangular box out of it, look at this point, distance from the xy plane is just z, the distance along z direction when you travel along parallel to z direction until you hit yz plane. That's precisely absolute value of negative. That will be absolute value of your z coordinate. 3 is the distance. Okay? What about 2, 5, negative 5? Let's say 2, 5, negative 7. Then you go from that 2, 5, and then negative 7. That will be absolute value of z coordinate again. Alright? What about distance to the xz plane? Then you have to travel this much until you hit the xz plane, right? This side is xz plane. That is exactly absolute value of the y coordinate. So C, that the answer is 2. Absolute value of the y coordinate. So just 2. Okay? What about the y-axis? So the distance from a point to a line will be a perpendicular distance. Then you have to measure through this plane, right? Plane perpendicular to the y-axis, right? This way. So that means that distance from that point to this, which is what? This point is 0 to 0, right? So this is 1, all right? This is 1, 2, negative 3. 2 to cancel. So basically this is 1 and 3 rectangle diagonal. So distance from here to the y-axis, so the touching point, perpendicular distance, that one will have the same y coordinates. So it's just like distance between 0, 0 to 1, negative 3 in the xz plane, just like that. So square root of x coordinate square and z coordinate square root of 10. All right. Likewise, distance to the x-axis, then you have to draw perpendicular distance to the x-axis. Then you have to draw that thing over here, right? This is 2 and 3. To the x-axis, then square root of the other coordinates, 2 squared, right? 9, so 13. Okay? So if you want to find the distance to the z-axis, then without z coordinate, square root of 1 squared plus 2 squared. This distance, right? Along the plane, horizontal plane. All right. Okay. Now finally, we want to talk about sphere. A sphere is set of all points which is equidistant from a fixed point called center. So, sphere definition. Sphere with center alpha, beta, gamma, and radius r is the set of all points in space which is r unit distance away from the center, alpha, beta, gamma. That means let's say this is that sphere. So your center, C is alpha, beta, gamma. Having a point, any point on the sphere, means that the distance between center to this, P, is on this sphere. Means that PC, the distance between center C and the point, is R. What was the distance formula? Square root of x coordinate, x coordinate difference square, right? Y plus y coordinate difference square, and z coordinate difference square equals R. And then square both sides, you get sphere equation. Gamma square equals R squared. This is R, this is gamma. So what do you see? All same is similar to the circle equation. You just have one more coordinate term. Okay? So if center is 0, 0, 0, then this will be x squared plus y squared plus z squared equals r squared, obviously. And then now, example 5, describe the graph of the equation that is x squared plus y squared plus z squared minus 2x minus plus 4y minus 6z minus 2 equals 0. Well, this is a sphere equation when you have x squared, y squared, z squared with same coefficient. Then we have to do, now in order to recognize this, we need to know, in order to describe the sphere, we need to know center and the radius. So we have to write it in standard form by using completion of square. So I'm going to write this y squared plus 4y and z squared minus 6z equals 2. Now, we want to half the coefficient of x squared, 1 squared, half the coefficient squared, half the coefficient squared. So you need to add here 1 and 4 and 9 to both sides. You know what to do with this completion of squares. X minus 1 squared, y plus 2 complete squared, z minus 3 complete squared equals what? 7, so 16, or 4 squared. 16, 4 squared. So it is sphere with center 1, -2, 3, right? 1, y minus -2, 3, and radius equals 2. Okay? Did I say 2? I'm sorry, 4. And radius equals 4. I already wrote it as 4 squared. Now, example 6. Find the equation of the sphere, one of whose diameter is PQ, where line segment PQ, where P equals -1 to 4 and Q is 3, 4, -2. Well, P and Q, let's say, P is over there, Q is over here. So P, Q are both on the sphere. Diameter means that they go through the center. So your center should be midpoint, this midpoint of PQ. Center of the sphere should be midpoint of two endpoints of the diameter. So average of x coordinate, which is 3 minus 1 over 2. Okay, average x is -1 plus 3 over 2, 2 plus 4 over 2, 4 minus 2 over 2. So it is 1, 3, 1. Okay? And the radius is distance between one of the points and center. 1, 3, 1 and this one. Square root of maybe 1 negative, so 2 squared, 4. 2 minus 3, so 1 squared, 1. 3 squared, 9. So square root of 14. Alright? So the equation is x minus x coordinate of the center square, y minus y coordinate of the center square, z minus z coordinate of the center square equals r squared, so 14. That would be the standard form of the equation of the sphere, of this sphere. And finally, example 7 is example 7 on your textbook, page 638. So take a look at your textbook 638. This is a shell between two concentric spheres. One is radius 2, the other is, okay. First of all, let's think about this one. X squared plus y squared plus z squared equals 4 would be sphere at the center 0, 0, 0. Whose center is 0, 0, 0 and radius is 2. This means inside sphere. Radius 2. When you have this is a unit sphere, sphere with radius 1, but this is the distance from origin to your point is greater than 1. That means sphere with the radius 1 and outward. Distance from 0, 0 to x, y, z, 0, 0, 0 to x, y, z is less than 2, square root 2. So inward, inside the radius 2 sphere, outside radius 1 sphere, right? So you have to have n, that means you have to satisfy this and this together. That's how you get this. So it's between two spheres. Radius 2 outside, radius 1 inside. This shell, thickness of one shell. But then, and z coordinate is less than 0. Out of the shell, z coordinate less than equal to 0, below the xy plane. Alright? And that's what you see in the book, right? Some kind of the half spherical shell, lower half, right? Okay. All right, this is the end of section 9.1. Thank you.